In today's video, we are going to delve into the concept of integration. I'd like you to know that integration and differentiation are inverse operations, just like addition and subtraction, multiplication and division. Hence, integration is the opposite of differentiation. In other words, it's known as antiderivatives. In geometry, we learned about easy ways to calculate the area of all kinds of polygons using specific formulas. Here we have shapes and their different formulas. We have square, rectangle, parallelogram, triangle, and lots more with their respective formula. However, things get much trickier when curvature is involved. In this very shape, we have a curved surface here. This is not a polygon because a polygon is always bounded. This is where calculus comes into play. To solve this, you need to understand and have a fundamental knowledge of calculus. Let's say I want to find the area underneath this curve, given by the function f of x equals to x raised to the power of 3. The best way to figure this out is with calculus. So this takes us to our super easy rule. In integration, the formula we deploy in solving problem is as shown. Integral of x raised to the power of n dx is equal to x raised to the power of n plus 1 over n plus 1 plus c, where n is not equal to minus 1. At this point, this denotes integral, and what it simply means is a command that adds stuff up. So let's say we have this problem. Integral of x raised to the power of 2 dx. Solving this problem, you first need to understand what your n value is. And from this problem, our n value is 2. So we are going to have x raised to the power of 2 plus 1, which is 3 over 2 plus 1 plus c, and this becomes x raised to the power of 3 over 3 plus c. Applying this same knowledge, let's go back to our graph. So from the graph, looking at this curve, we have the lower boundary to be 2 and the upper boundary to be 4. So we are going to apply our super easy rule to solve this problem. To find the area under this curve, easy rule here, you know the lower boundary from here is 2 and the upper boundary is 4. We are simply going to deploy the formula, and this is as shown. Integral of x raised to the power of 3, the lower boundary is 2 and the upper boundary is 4 dx, and this becomes, first you need to know what your n value is, and here our n value is 3. So we are going to add 1 to it and also divide, and that becomes x raised to the power of 4 over 4 bounded by 2 and 4. Solving this further, we are going to have x raised to the power of 4 over 4 minus x raised to the power of 4 over 4. We are going to substitute the upper boundary and then the lower boundary. The upper boundary was 4. So we are going to put 4 wherever we have x. So this becomes 4 raised to the power of 4 over 4 minus 2 raised to the power of 4 over 4. Remember, the exponent tells us the number of times the base repeats itself. So this means 4 is multiplying itself 4 times, and that is 256. So we are going to have 256 over 4 minus 16 over 4. 256 divided by 4 is 64 minus 4, and this becomes 60. The area under the curve is 60. We'll be solving some questions that deals with applications of integrations. This question reads, find the area enclosed by the curve y equals 6x squared and the x-axis between x equals 1 and x equals 4. We are going to deploy our formula and solve this problem. Let's delve into this concept more. Our formula reads integral of y dx a b. In this case, our a is the lower boundary and b is the upper boundary. 3 questions. What are you given? What are you told to find? What's the formula that relates what you are given with what you are told to find? Here, we are given that our y equals 6x squared. Our lower boundary equals 1 and our upper boundary equals 4. The next thing we are going to do will be to substitute these values into the formula. So that becomes area A equals integral of 146x squared dx. Solving this, we need to understand what our n value is, and our n value is 2. So that becomes 6x 2 plus 1, which becomes 3 over 3, bounded by 1 and 4. Remember that 6 divided by 3 is 2. So that becomes 2x raised to the power of 3. If we must substitute these values, we will start by putting the upper boundary first, the number on top, then subtracting with the number below. So we'll put 4 wherever we have x. That becomes 4 raised to the power of 3 minus 1 raised to the power of 3. Always remember that the exponent tells us the number of times the base repeats itself. So this becomes 2 into 64 minus 2. And 2 times 64 is 128. So that yields 128 minus 2, which becomes 126 square unit. Therefore, the answer to this question is 126 square units. That is option C. In our next video, we will be solving a lot of complex problems, and we'll also be giving you some quizzes to see your level of understanding. Thank you. Don't forget to subscribe to our channel. Have a great day.